So my name's Mike. Many of you have probably talked to me before. I've made a bunch of the videos, so you might recognize my voice and everything. Today we're going to go through 3-axis Pro. I have a very simple looking part on the screen, but what I did was I made a weird kind of fixture for it. And I want to set this up so that I can use this fixture as pretty much what we're going to use it as gouge check geometry. So here's the part right here. And then if I turn on the fixture, we can see this is how I plan on holding it down, we'll say. So I got these clamps in the way here, and I want to avoid those as I cut around this part. Now, with this part, I would probably just put this in a lathe and do it because that's easier, but maybe you ain't got a lathe. I work with a guy that doesn't own a lathe. He's been using a mill to do parts that should be done on a lathe for many years now. He is finally getting a lathe, so yeah, maybe one day he'll figure that out too. But right here, I have my fixture. I have my solid model, and you'll see they're just on separate layers. And then right here, I created some stock. So stock's the same kind of thing with something like this. Yeah, you could throw it in a lathe, or you can go put it in a vise, cut it round. I mean, at that point, you could really do this part from a vise, but we have this fixture so we can be more repeatable. Maybe we've got to make a bunch of them. This final one down here is this Op2 solid model, and that's for a second operation, and it's actually the same exact solid model as Op1, and I'll show you why that is here in a few minutes. So to get started, we're going to do this job pretty much our normal way. The big thing is when you start the job, I would recommend turning the fixture off for now. Just leave the fixture off. That way, you're only creating stock for your solid model. Granted, I have stock that tells it where the stock is and everything, so I don't really need to know any of that information. So what I'm going to do is I'm going to go to my CAM defaults here on my CAM tree, and I moved my CAM tree over. I'm so used to having the CAM tree right next to BobArt from all the years of doing this that I just moved it over. So my operations tab is there, and my CAM tree is there. So I'm going to right click here on CAM defaults, and we're going to start a new job. All right. I'm going to use just the BC3X mill, and I'm going to go directly to the stock wizard. From here, we can pick our workpiece. This model represents the final finished part on here, and so that's what I want to pick as my solid model for my workpiece. If you don't have a solid model, remember, like you're just doing 2D stuff, you don't need a workpiece. You don't even need a workpiece right now while we're doing this. But since I have it, it's right there. I'll just pick it. And then I'm just going to hit the stock wizard here. So what this is going to do is create a rectangular piece of stock. But if I have my fixture on, it's going to create a piece of stock as large as the entire fixture that we have. And I don't want to do that. I want to go and make solid stock because I've created a layer with that stock. So I'm going to say solid model stock. I'm going to turn off all my layers but the Op1 stock and turn off just everything else. I can pick my stock and then say, let's go ahead and calculate that stock. And there it is. From here, I'm just going to hit next. And then right here, we have our origin. Now, I like to use the top of my fixture right here for my origin, and that is actually sitting right at XYZ0, or sorry, Z0, sitting right at Z0. So I'm going to use XY0 for the top dead center here, and then I'm actually going to drop Z down to 0. So my origin is XYZ0 every time. Now this work offset height, I have the ability to show my simulation machine. I can actually see my machine inside the simulation. So one of the issues you run into is when you start machining, you'll see it cutting through the table of the machine. So this work offset Z here is what I can use to lift this part up virtually inside my simulation. If you don't have the Machine Simulation Pro, you don't see the machine when you go into your simulation, which you can turn off. So there's also that. You can turn it off. If you don't see any of that and you don't have that on your license, you don't have to do this. You won't have to mess with this value at all. You shouldn't have any errors come up. But for me, I'd get a bunch of errors telling me that I'm machining through my table, and I don't want that. So I'll figure that value out here in a second just by hitting OK. And then I'm just going to go to the Evaluate tab and say Measure To. And what I'm going to do is I'm going to measure from the top edge of this piece of stock that I made down to the edge of the bottom of the fixture. And then I'm going to look at my value for Z right here, 4.5866. So I'm going to copy that number and I'm going to cancel out of the Measure To. Then I can just go back to my CAM tree. I'm going to double click on Machine Setup 1 because I'm in version 35. You can do this in 34 as well. And I'm just going to paste that number right there. Now, really, that's going to lift me up a little bit more. My Z could be at the top of the part. I really should just take out how much I need to lift up from there. Let's do that real quick. So all I need to do, I'm going to hit OK. I'm going to measure this one side. Thinking about it again, I don't need that much height. So it's a total length of 1.2205. So if that's where our origin is, that's the distance I need to move up, 1.20 or 1.2205. So here, I'll go back in and I'll put that in, 1.2205. And that should put this flush to my table of my simulation. The other value would be if I had my origin on the top of the part, then that would give me a, that would lift the whole part up, the whole fixture and the part and everything. This should just lift up. You'll see it when we get there. You'll see it. All right, so I'll say apply. And then right here we have our job pretty much done. Now, before we go any steps further, we're going to turn off every layer but the fixture. And there it is. I can blank out my stock just to get it out of the way. And then right here with fixture, same as what you'll see with workpiece or when you clear geometry, you have a little red plus sign. Now, the little red plus sign for fixture doesn't always need to be corrected. The only one that has to be corrected every time you see it is going to be the one for geometry for your tool paths. Workpiece will have a little red plus sign. Fixture will have a little red plus sign. There's a bunch of in the 3-axis features that have a little red plus sign. The only one that has to be resolved properly is the geometry. Because if I pick the geometry right, even without a boundary, I can machine parts a little bit better. So I'm not going to, or I'm going to go ahead and pick my fixture now. So this is real simple. I just have the whole layer for the fixture on. I right click, I say reselect, and I'm just going to drag a box over the whole fixture. And this is going to allow the simulation to actually open this fixture so I can see it inside my simulation. So I'll hit OK, and there we have it. So we have our workpiece picked, which is our solid model. And now we have our fixture picked, which is our whole fixture. All right, from here, we're going to right click on Machine Setup 1 and go down to Mill 3-axis. Oh, almost picked the wrong one. And I'm going to start by selecting geometry. Now, the geometry for this is just the solid model. Make sure you don't pick the fixture. The fixture is going to be used with gouge checking. This one is going to be just the whole model right here. So we'll pick that. I'm not going to pick a boundary because the tool paths we're using should recognize the stock, and so that'll work just fine. So I'll hit OK, and then hit Next. Right here for the feature page, our top of feature is 3.3662. That's from 0 up to the top of the part, and so we don't have to change that. We're just going to hit Next. And right here's our strategy. All right, so for the tool paths, we got to choose which ones are going to be the best. And with a part file like this, where it's basically I need to rough it some way, so I'm going to use an advanced rough because that's the best roughing tool path, especially for 3-axis Pro. If you don't have 3 Pro and you're still here, the Z-level rough can do a decent job, but it may not finish floors as nicely as, say, the advanced rough will. And then looking at this part, it's really a big wall. We got a big wall, kind of steep wall. So I'm going to use something that can clean up walls. Z-level finish or the advanced Z-level finish should be able to do that. And I'm going to use the advanced Z-level finish because that one has angle ranges. So I could tell it not to waste its time trying to cut up here because it's not going to do a good job anyway. So we have our advanced rough in our current operations. Now under available operations, I'm going to move over an advanced Z-level finish. So I'll just move that over. And then the last one is going to be pretty much clean up the areas that the Z-level finish doesn't clean up. And for me, that's either the planar or the advanced planar. And again, I'm going to use the advanced planar because I can do angle ranges. And so I can limit it to only output between, say, 0 degrees to 30, 35 degrees. So it only does this small, shallower section where the Z-level will do all the steeper stuff. So I'm going to move that over, and there we have it. From here, I'm just going to hit next. Now, this page, normally not a big deal, but if for 3-axis, it is an important page because if you go and output your code and you see that the whole thing comes out in line moves, it's because of this right here. That arc fit button is turned off. And most of the 3-axis toolpaths will be adjusted by that. They'll actually have their arcs loaded into the G code. If you forget to turn it on, again, you'll get all line moves. But also be aware there is toolpaths, well, really one, the equidistant toolpath, that no matter what, it will not output arc moves. That's a point-to-point based calculation. But we're not running that. So these 3 are affected by this button. So I want to make sure to turn that on. And again, that's just going to put arcs inside the G code. All right. Tolerance, I never really mess with the tolerance. I just leave it right there. Usually does a pretty good job. Potentially making it a bit larger. So say you were to go to a thou. That will give you a looser kind of arc fit, where making it smaller could give you tighter arcs, more toleranced arcs, but they could also be broken into smaller segments every time. So there is also that that issue you could run into. But half a thou is pretty much what I've been using since I started doing this, because my big thing with going through these 3-axis toolpaths, especially the 3-axis, is try not to change anything. If I can go through this whole toolpath and only go in and put, the tools that I know I'm going to use, feeds and speeds for sure. I'm not going to be doing feeds and speeds today. I use GWizard for feeds and speeds calculation. So I just use that and then plug them back in. But other than that, like depth of cut, step over, a little bit of that's going to be worked out while I do my feeds and speeds, because GWizard, I tell it what depth I'm going to go and I tell it what step over I'm planning on using. And it'll tell me if it's too much for my tool and I can adjust from there. And so I usually do my feeds and speeds while I'm doing I usually set my depths and step overs while I'm doing my feeds and speeds, so I can get a good idea of what the tool's capable of handling. And if you haven't looked at GWizard before, I'm not sponsored by him or anything. He doesn't work with us. I just think his software is fantastic. I really have no bad things to say about it. I keep finding new things in it every time I go into it. But most importantly, it's been dead accurate for me for the parts I've been doing. I got one guy that cuts a lot of aluminum and wanted to speed things up. And so we looked around, did some research on GWizard. He was one of the first guys I talked to that used it. And man, did it make a big difference. He was cutting at, 20 inches a minute, a quarter inch deep or whatever. And looking through GWizard and being able to modify settings, we found, we're now running it closer to over 100 inches a minute on a lot of these cuts. And we're doing them a bit more aggressively. So getting into doing the high-speed machining strategies and stuff like that. So if you haven't looked at it, I couldn't recommend it anymore. It's by far one of my favorite programs. Like I said, I don't work with the guy. Bob does that at CNC Cookbook. If you're looking for the website, it's cnccookbook.com. Check it out. It is a killer program. So from here, now that we have our arc fit, that didn't have anything to do with GWizard or anything. I just went off on a tangent there. So the arc fit, now we have arcs in our G code program. Again, if you forget to turn this on, this is one of the few things you don't actually have to recompute all your tool paths for, which I don't know how much you guys have gotten into 3-axis, but I've done this enough times that I'll calculate a tool path. And it's a long one. So I'll start it before lunch. I'll go take my lunch. By the time I come back, it's all done. And then I go to post the code and realize I forgot to click that little button right there. You don't actually have to recompute. The arcs are in the G code by default. By not having this button checked, the posting engine actually just outputs all the line moves. So just to be aware, you don't have to recompute with that one. Next, we get to the tooling page for the rough, for the advanced rough. So I'm going to go with a 1/2 inch, but I'm going to use a flat end mill. So I'm just going to say the corner radius is going to go to 0. There we have it. All right, now remember, you can change your tools right here by unchecking System Tool and then clicking this drop down, and you could say Modify Tool. Now, I don't know if I actually said it in any videos that have been out for 35. I've only really done the getting starteds, but this does not modify the tool inside the library. We were all very confused on that and had a big talk with development just a couple weeks ago about it. Because all of us thought when you change this, it changes the tool inside the library. That is not the case. Unfortunately, I've requested that it does, or they find a way that we could, because I like to modify a tool once and never have to change it again if it's the same tool I'm using. So, yeah, just be aware it doesn't change it. But for the longest time, if you were using carbide tools, you had no way of changing it to a carbide tool except for going into the library, changing the tool in the library, and then updating it, and then, picking that tool. But I mean, it is really recommended. If you're going to make changes to the tools, do it through the library so that the next time you go back and pick that tool, it's done. It's already good to go. Again, big thing here, I'm not going to worry about this because I am not using BobCAD to calculate my feeds and speeds. So to me, the tool material is irrelevant. I'm going to use a carbide end mill, all right, at the machine, or I'm going to use a high-speed steel, or I'm going to use an insert. My feeds and speeds are going to be based off of whatever tool I'm using. So changing the material for me isn't too important, but if you are using BobCAD to calculate your feeds and speeds, good luck. But yeah, try it out and see what you get. Like I said, G-Wizard's my way of doing it. So I don't really worry about the material. Most important thing I'm paying attention to is the protrusion length. But even that, I'm not really paying attention to, because when I run the simulation, if my holder hits the part, I'll know. It's going to turn bright red. I think we're going to have that issue on the finish passes because we're going to use a little 3/8 ball. So we'll see it and we'll fix it because there's a really quick, easy way to fix it inside the system for version 35 here. So right here, we'll just go next. We got our patterns page. So offset out, offset in. The offset out is going to start from the inside and work its way out. Offset in is going to start on the inside and start on the outside and work its way in. We have our morph spiral, parallel, and then the adaptive roughing. I'm going to keep it pretty simple here. Like I said, one of my goals when I go through this tool path is to change as little as possible. So by doing an offset out, I'm doing kind of the most traditional pocketing strategy that you can really do. And that's the default. Down here, we have our method of zig or zigzag. I'm going to go ahead and zig so I can keep that tool moving in one direction the whole time, especially with a round part. Keep it moving in one direction. And then your cut direction. I want to climb mill. So I'm just going to leave it on climb. Now, one of the things we can talk about is the start location. I didn't add any points to this job, but you can pick points on where you want to start. So if we don't like our start locations at the end of this, we'll go and change them. We'll try and pick a different start position. So for now, I'll leave that off and we'll just hit next. Right, here's our parameters. So again, at this point, I would have already kind of gone through the work to figure out what I'm comfortable with this tool taking. I have a 1/2 inch carbide end mill. I'd plug that all into G-Wizard, and then I'd start punching some numbers in. The cool thing about G-Wizard is it has a deflection calculator, and it'll tell you if you're going to break your tool. And so far, from using it for going on probably 3-4 years now, when the thing tells me the tool is going to break, when G-Wizard tells me it's going to break and I've ignored it, I've broken a tool every single time it told me that. There's actually a little slider bar in it. Let me see, dude. I might have it on here. Hold on. I didn't think I had G-Wizard on. I did load it up. Okay. I'll just pull this up real quick just so you guys could see kind of my process of going through feeds and speeds. There is a little bit of setup work that you have to do beforehand, which is you're going to define your machine. So over here with the machine, this is just a generic VMC. And I could go in and there's actually a bunch of machines in here. So you pick the machine you have if it's on this list. If not, you can add your machine. Basically, what the system needs to know is how powerful is the machine? What's the RPM? What's your minimum? What's your spindle horsepower? And what's your max feed rate? And it uses those values to calculate the feeds and speeds. Feeds and speeds is done right over here. Now you'll have your machine selected. Right here, you'll tell it what material you're cutting. So I'll say 6061. And then right here, you can click on where it says carbide end mill. And in here, I can pick all different types of end mills. If I go to just the end mill category, I could actually choose all different types of end mills down here. So you can pretty much figure out feeds and speeds for most of your tools. Right here's the material. So you got carbide, high-speed steel. You even have indexables right up there. How many flutes you got? Now, one thing that I kind of skipped over for a long time was setting up my shank diameter and didn't realize it, but I use a 5/8 tool quite often. And so I was getting weird numbers because my diameter was 5/8, but my shank was a 1/2 inch. So it was a tapered up end mill. And it calculated it. And I was always wondering why I was getting different values compared to other people. And it's because I wasn't changing all this information. So fill your tools out correctly if you use this. There's even a tool crib where you can save your tools. But I'll hit OK. So it now knows that the diameter is 2 inches, or 2 inches, a 1/2 inch. There's 2 flutes on it. The stick out, I'll say, is 1.75 right there. And then right here, I could go in and say my cut depth. So I want to go at, let's say, 200 thousandths. And my cut width, my step over, also 200 thousandths. So what this is telling me is I'm going to be running at 4,000 RPM, climb milling. There's some tips right there. My feed rate is going to be 32.661 inches per minute. And my plunge, if I want to plunge vertically, just plunge in with that tool, 16 inches a minute. If I want to do a helix, it's 31. And if I want to ramp, it's 31. Now, right here's the little conservative versus aggressive. How do you want to be when you cut this? And so what I'm going to do is just make this tool a little bit more drastic. Say it sticks out 4 inches. And what that does is it brings the deflection up. Now, if I use these feeds and speeds, this says it could still handle it. Now, when you get into real long tools, take this with a grain of salt even. But what I want to show you is if I go 5 inches, I'm now over my deflection. This tool should break 100%. But if I take this little slider bar and I move it down, I can slowly move this to a point where it stops being red. And I can actually get it down in the green. And what this is doing is it's slowing the tool down. So you can see it's in the green again. There's still some good deflection happening, but at these feed rates with a tool sticking out that much, I should be able to run. Again, crazy long tools like this, take them with a grain of salt, all right? But that's what I do. I didn't take all this, and now I know, at least with this tool, or let's go back to our 1.75. All right, and I'll go back to being real aggressive because that's a real small deflection. I could take 200 thousandths in the depth and the width, and I shouldn't have any issues. And from here, I could even go up and, try and take more. Let's say we wanted to do cut width, we'll keep there, but let's say cut depth, we'll go to 300. Brought it down just a little bit. Brought the deflection up just like 2%. So it's something you can play around with. I definitely recommend this one. This is how I calculate feeds and speeds. Everyone always asks how I do it. This is my way. And, yeah, I will push this product till the day I die. So now I know what I want to do with my depth. So I'll say depth of cut, 0.2, step over, 0.2. My rule of thumb usually is keep it under 50%, unless I'm trying to be real aggressive. But usually I'm not going that route. The problem is this is going to leave these big 200,000 steps along the part that my finish tool, my 3/8 ball, is going to have to encounter, which it might be a little bit more material than it's expecting. So what I can do is turn on intermediate steps. Intermediate steps are extra passes that go in and cut the areas that leave those large steps. I'm going to tell it to just cut those large steps one more time into 200 thousandths passes, and that's just fine. You could even tell it to detect stock thicker than a certain size. And what this does is as it creates that intermediate step, or the steps on the part, if there's an area that's only got 15 thousandths worth of material, we're not going to cut that again. We don't need to. That's already within our allowance there. So I'm not going to mess with that. And honestly, you can turn it on. I usually set it to whatever my allowance size is what I turn on. Anything greater than 15 thousandths, go ahead and cut it. But if you leave it at 0, you'll get an extra pass on every step that you have. It's not going to add much time to the job, but I guess that really comes down to how fast you're running. If you're only running at 3 inches a minute, doing an extra pass is time. So tolerance, it's a half a thou. I'm really not going to mess with that. I like half a thou. It calculates fairly quickly, and it gives me a good result. If I got to be more accurate with that, I could go down to a tenth. If I want to be less accurate, but I want it to calculate faster, I could go down to, say, a thou. And again, a thou is going to get us going, calculating faster, but the tool path is going to be worse, where half a thou is a good middle ground. And then the final one, if we were to say a tenth, this is going to take a lot longer to calculate, but the overall tool path should come out with a just a better quality than the half thou. But again, half thou is a good value to start with, especially in kind of your initial going through this. There's going to be changes that we're going to make on this tool path. I never get it right the first time. So there's always going to be some changes we're going to have to come in and make. This is also a huge reason on why I don't go and change a lot of settings right off the bat. Because then if I do get a weird result, I have no idea how I got that weird result. I don't know which feature is really causing it. So we're just going to go ahead and hit next. Sorry, I'm using 15 thousandths. Let's go a little bit more. I'm going to leave 20 thousandths for my allowance. That's what the finish tool is going to get to clean up. So we'll go next. Right here for the leads, depending on the tool. That's the biggest thing here. It all depends on the tool. Can I plunge or do I have to ramp? If I can plunge, I like plunging. It's an easy thing to control, not even with where it's located per se, but the plunge itself is usually not in the middle of the part, not going to cause me any problems. Ramp is for the tools that I don't want to plunge with. So right here we have our ramp, and this advanced rough comes with a bunch of options for the ramp lines. You can do zigzags and spirals and profiles. And then there's this automatic option. So what's the difference? Well, if you choose line, every time you lead into something, you're going to use a line. Same with a spiral or a zigzag or a profile. But if you go with automatic, you can use a line on one entry and a zigzag on another entry. So automatic works out pretty good. I'm going to go ahead and just say, let's plunge in single depth. I'm only going 200 thousandths. And I'm not going to add a lead out right now. So we'll just hit next. For the options, I don't have a roughed out part, so I'm not going to be rest roughing. I'm not using a bigger tool here. Rest roughing is only going to be used when you've cut the part once with a large tool and you want to come back with a smaller tool and remachine that area. Down below that, we have our machine flatlands. This is one of the buttons that I do turn on. I pretty much turn this on every time I see it. I like this feature. It does a couple things. One, if you have your depth of cut at, say, 1/4 of an inch, and you have a floor 1/8 of an inch down on the part, the tool path is going to ignore that floor because it's going to 1/4 inch deep, and that floor is not 1/4 inch. With this, it'll actually go back and remachine that floor that fell in between your steps. It'll also ensure that you get a decent finish on the flats of the part. You're using a flat tool right now, why not? It's even the reason why we added on the parameters page a side and bottom allowance. So you can leave material for the ball mill to clean up on... hold on. Can you guys hear me still? Can someone just let me know they can hear me? I got someone saying they lost sound. Someone just let me know. Can you hear me? You can put it in the questions box. Okay, thanks, Ron. All right, thanks, guys. They all start showing up right at the same time. All right, cool. All right, give me a second. I'm clearing out all your questions now. All right, done. All right, so Bob, I don't think you can hear me. Bob, if you can hear me at some point, sound should be working. I didn't block you or anything. It says you're connected. All right. Well, hopefully we can figure that out. All right, so I forgot there's some Roberts in here. The guy that asked his name Bob in the meeting. Here we got a few of you anyway. So there's more than one Bob in here. You guys are doing great. This is the 30 of you in here right now. All right, so depth of cut, step over. I already talked about that. Back to here. So hold on, I started changing things. All right, so right here we're going to do the machine flatlands. Like I said, just turn it on. It usually doesn't cause problems. Now, that's not always the case, but, you know, sometimes it does, sometimes it doesn't. But 99% of the time for me, I'm turning it on. All right, next we have our links. I like to use the S-link, and yeah, I like the S-link. It gives me a little, what's the word I'm looking for? Tangent lead out, so it leads out of that arc tangently, and then it'll lead into the next cut tangently. So I like that one. Next, we have Gouge Check. Now, most of the time, I would tell you guys to ignore this page. And for now, we are. We're going to come back and look at this here in a few minutes. But this is one of the few times that I know I'm going to use Gouge Check because I actually have a fixture in my screen here. So I'll hit next. Right, here's our advanced feed rates. I'm not going to change anything on here. Convert rapids to feeds is only if your machine has issues with dogleg rapids. The linking feed rates, not a bad idea to get better blends. And I'm not doing any adaptive feeds. From here, again, no MDI. I'm not going to use any MDI. For those of you that are running 34 still, you don't have this page. This is new to 35. It's the manual data input that people have been asking for hundreds of years now. It's here. We have it. It's in there. It allows you to go in and define commands. If you want to, at the end of this tool path, have it, put raw text in. You can do whatever you want. You can put raw text in is how I've been using it so far. A lot of times I'll do it to stop the machine, give the guy a chance to look. In the past, I didn't have a way to add an M00 sometimes. I had to add M00 all the time or none of the time. So this gives me the ability to say after this tool path is done, after this operation's done, let's call this, stop. And then I can add a command to it. So you click on raw text, you say, I want to add that command. And then in your raw text, you could say, I want raw text, or you could put it in as a comment. So if you want to put a note in here, you can do that. And I can just go, M00 and then hit, I'm going to go next. But this will now output an M00 after just this tool path, depending on the post. It could be other things in my post. But this is going to output after the tool path. With an M00, give me a chance to go look at the rough and say, okay, that's great. Now let's move on to the finish. So next. Right here we have our Z-level finish, advanced Z-level finish. But if you're using the Z-level finish, the steps are pretty much the same. They're both good at the same bits of geometry, walls. They like cutting walls. So what I'm going to do here is I'm going to pick my tool. I'm going to just type it in. I'm going to say 0.375. I want to use a 3/8 ball. And the way I like to do the ball mills is take your diameter and plug it into your corner radius and then divide it by 2. That one works well, especially when you're getting into using smaller tools like 1/16 of an inch end mills and little ball mills. You let BobCAD do the truncating of your numbers by doing it that way. It's set to tool number 3 now. If I go up to the tool crib, I have 3 tools in here. And the reason that is this bottom tool path hasn't been changed. So it still has that 1/2 inch ball. One thing to take note of, down here in the crib for 35, you now have your automatic tool numbering. And you could tell it to renumber based on usage or renumber based on pretty much when it was added to the tool crib. So the first tool added was the 1/2 inch ball. Second tool was the 1/2 flat. Now we're using our 3/8. So that's why it's tool 3. But if I say renumber by usage, and go by our tool number again, we're using our 1/2 inch flat first, then our 3/8 ball, and then we're not even going to have this third one, but that's the final tool path. All right, so you have those options, or you can uncheck it and type in the values you want no matter what. So we'll hit OK. And again, feeds and speeds, next. Right, here's our patterns. I'm going to go from the top down. I'll keep it as a zig so it moves in one direction, especially with a round part. Zigzag would make it flip back and forth, so it'd actually come to a stop in reverse directions. I'm going to say zig, and I'll go ahead and just climb mill. From here, I'll just say next. For the parameters, I'm going to go with a depth of cut of just 50 thousandths. It's not the greatest finish in the world, but for those of you that have been here with me before, I'm not looking for my final finish right off the first calculation most of the time. I want to find out if I'm even on the right track. Is this tool path even close to what I want? All right. Other than that, we have our tolerance. I'm not going to use any fancy finish buttons or anything like that. We have our top and bottom of job. Allowance is set to 0 because we're not trying to leave any material anymore. So next. Leads, going to go with the defaults. At this point, we're not plunging into much material. Next, again, we have our options. I pretty much always turn on the 3D Extense option if I have it available. That's just to help me out. And then right here, I'm going to turn on my angle range. Now, this is where you find it. The picture values are pretty good values to start with. So for this Z-level finish, this advanced Z-level finish, it's good at cutting walls. So I'm going to limit it to cut between 30 and 90 like that picture says. And that's going to just cut the steeper walls. Next. Right here we have our links. I'll go with an S-link. That's fine. Right here's our linking position and our start location for this toolpath. The advanced rough has it on the, where was it? On the patterns page is your start location. It's on the options page. Sorry, it's leads. Did I pick the wrong one? Oh, sorry, it's on the links page. Oh, yeah, because it's your linking. So, yeah, this one, again, uses a point. It does not plunge into that point. It aligns with that point. So if you put a point here, we're going to say, yeah, plunge in there, but it's going to feed to its cut. So if you put the point out here, it's going to plunge there and feed to where it needs to start. Other than that, we're not using any of that, so we'll turn all that off. Go next. Gouge checking. Again, we are going to use this here in a few minutes. Right here's our advanced feeds. And finally, we get to the MDI. And on this one, I'm not going to do anything. So next. Advanced planers. So this time, instead of going into the tool crib like we've done for years, what you can actually do is click System Tool here. And if you click this drop down, if the tool exists in your library already, you can actually go in and pick it right there. And it's going to allow you to pick any tool that's available for this category of toolpath. So when you do something with like a V tool, a T cutter, a dove mill, especially like a 2-axis toolpath that can use a lot of those different styles of tools, you'll get a big list of tools right in here. If you go up to your tool crib, though, it will list them all out in the side and you can get your own. So I'm going to say renumber by usage and hit OK because this should be tool number 2. And then we'll go next. Now, this is just the planer. I'm not really going to get too fancy with this other than I'm doing the angle ranges. So right here, I'm going to do a zigzag. My lace angle is going to be at 90 because the lace angle at 90 is going to run along my y-axis. Lace angle at 0 is going to run along your x-axis. And I'll start at the lower left. Next, we get to our parameters. So again, I'm just going to go 50 thousandths for the step over on this. No real changes of the tolerance. Cut holes, ignore holes, top or bottom of job. None of that right now. Right here we have our leads. Just going to plunge in vertically. Next. Options. I always turn on 3D Extense. And for this one, I'm going to turn on the angle range. So I'm going to tell it to go between 0 and 35. And yeah, just give it a little bit of an overlap between the two of them. We'll go next. Right here's our link so we can follow. We can make a little S-link, or not an S-link, a horizontal vertical step, direct. We can make a blended spline and a full retract. From here, we'll just hit next again, and we get to our gouge check, which we will be using shortly. Right here's our advanced feeds, no changes, and right here's MDI. Now, for those of you that have done tool pathing before, or those of you that have worked with BobCAD before, we all know that the worst time to lose all of our work is literally right now. When we hit compute, if the software crashes, I haven't saved it, so we're going to lose all the stock, we're going to lose everything. So instead of hitting compute on this one, just because I should have saved earlier, I'm going to say finish, and then I'm going to say save. Just so I could save that part before the tool path was calculated. All right, sound check works fine, but no sound on the webinar. Let me send a message. All right. All right, Eric, yeah, you can hear me. All right, yeah, one of the guys is having issues, so I just sent a message to try and rejoin, see if it fixes it. All right, cool. So now we can go in, and I should have calculated that while I was doing this, but I'm going to right-click on the Feature 3 axis here and say Compute All Toolpath. And we'll just wait. This is a good time. If you guys got any questions so far, go ahead and throw them in. Bob, can you hear me? Well, I know one Bob can hear me, but the other Bob, the Bob that left a second ago, is your sound working this time? I'm talking, so I don't know if he can hear me. So there's the tool path for everything. And I always like to start by blanking out the tool path. And if you guys didn't know about it, if you go up to your settings here and you go to CAM, there's a button here called Auto Blank New Items. Fantastic button if you're like me and you like to blank out your tool paths right away. The only reason I don't have it enabled is because I do videos and work with guys, and if the tool path doesn't show up, it's real confusing. So if you are aware of that and you want to turn it on, it's inside your settings. It's an awesome feature. So here's the advanced rough, and again, this one recognizes the stock kind of automatically. Right here we have our advanced Z-level finish, and right here we have our planer. The problem is, if we were to go and turn our fixture on and look at that, we're running right through where our clamps are supposed to be. All right, Bob, good to hear. All right, Bob's got sound again. So we have our clamps, and I don't want to touch them. I want to stay away from them. Excuse me. So the way we do that is with Gouge Check. So I'm going to go into my feature again. I'm going to go down to the Gouge Check tab of the Advanced Rough first. I got to do this for all three of them. And I'm going to turn on the Check 1. From here, I don't want to gouge check against the feature geometry. I don't want to avoid cutting the part that I selected. I want to go and pick check surfaces. These are surfaces that we're going to stay away from by a certain amount. I'll say 20 thousandths. Now, one big thing we got to take note of here. You have to be accurate with what we're doing right now. If these clamps aren't in the right spot, if this clamp is 20 thousandths out of position when you go to cut it, you can crash your machine. This has to be set up perfectly. All right, so that's kind of the most important bit of information. What we have here in BobCAD has to match the machine as perfectly as we can get it. All right, so by saying stay away from it by 20 thousandths, I should come short and then cut around it. Now, the surfaces that I'm going to pick, I'm just going to click this button right here to pick the geometry. I'm going to turn on just my fixture layer. And I like to go to a front view. So I'm just going to hit Control-2 on my keyboard to go to a front view. And what I'm going to pick is all of this geometry. Not all the way down, but just to right here. All that. Now what you'll see is if I turn my model on, we're saying don't touch any of those pieces of geometry. Don't touch them. So even if we were coming over here, we'd stop there. We technically don't need the holes, but it's not going to hurt anything. So I'm just going to scroll down in here and hit OK. From here, I'm going to go to the next Gouge Check page. But before I do, don't forget about this button down here called Apply to All Operations. I'm going to click that. And now when I go to the next Gouge Check page, it's set up the same way. So that one's turned on. One thing to take note of, and I didn't know this till today, when you do the Apply to All Operations, it remembers all the settings we entered into here. It does not pick the geometry for us. So I just got to go in and do my check surface, front view, turn that guy off, repick the same geometry, and hit OK. And then if I go to my final Gouge Check page, I'm going to go in and just do the same picking of geometry right there. I'll hit OK. I'm going to hit Finish, Save, just so I don't lose anything. And this might take a second. This is a pretty large file. And there we go. So, Control-7 gets me my isometric view. So there's my advanced rough. And you'll see it running through the clamps again. So I got to fix that somehow. That shouldn't be happening. What's going on here? Well, this worked perfectly when I was practicing. Give me a second. Let me check one setting on these. So I'm going to go to Gouge Check here. My check surface, I say there's my allowance. And I'm going to retract my tool. I'm going to say trim and relink. So let's apply that to all operations. Finish. Again, save. I always like to save just so I don't have to redo any of this stuff. And then we could go ahead and recompute that now. So compute all toolpath. Huh, wonder what's going on here. This should be working. Yeah, we'll have to, hopefully, we'll see. We'll find out. It's either going to work or it's not. And we'll figure out what's going on. Like I said, in practice, this worked perfectly. So I recomputed, right? I thought so. I don't know. We'll see. All right, so let's see. So there you'll see it is now trimmed and relinked. Which the other option, I was going to choose that in a minute and show you guys the difference of it. Normally, the way that other one works, where it just says Retract Tool, it just lifts the tool up and then rides across 20 above and then drops back down. This one's going to go to our clearance, which I don't really want, but I'll deal with it for now. Right here, we then have our advanced planer. And so it's kind of going in and cleaning everything else up. So between the three of these tool paths, we should have a pretty decent finish coming out. Again, you got to remember, this is 50,000, so it's not even that great from the start. All right, now that the tool paths are done calculating, again, I don't want to wait for them. If I crash the software, I don't want to wait for it. So I'm just going to hit save once again. You'll see I am obsessed with saving. And it's just, I've gotten burned enough times, and pretty much if in my head I think the thought that I should save, BobCAD knows it. And if I ignore that thought, it likes to crash. My computer just knows that I was thinking about saving. So be aware. All right, so now what we're going to do, we don't need the fixture layer turned on. And I technically don't need this one, but I'm going to go ahead and say start simulation. Now, if you guys didn't know, and this is pretty cool, if you go up to the settings and you go down to CAM, you can choose your simulation window now. You can have the embedded view like we've always had where it opens inside of BobCAD, or if you have multiple monitors, you can now set it as a separate window. And what's cool is you could set it in, I got 3 monitors here. I could set it on my right monitor and I could watch it. Now to reset, so maybe we make a change to the simulation, you can actually just click start simulation again and it'll reload the simulation on your other monitor. But for this one, I'm only using one monitor, so I'm going to use the embedded window view there. And I'm just going to hit OK. All right, so we'll go ahead and start our simulation, see if we find any errors, and correct those errors. I know we're going to find some errors. Pretty sure the 3/8 ball mills that we selected, unless I got some different tools from earlier, they should be too short, so they're going to gouge. So this is what I was talking about earlier. My simulation has the ability to show me my machine. And so the value that I entered in to my machine setup here, this 1.2205, was the distance to go from this plane, which is my 0, my origin 0, and just lift it up virtually. So there's my machine, there's my part, clamp down on the table, and then I can hit run. Now, I don't want to run too fast, so I'll slow this down, not too slow, but I want to make sure we catch this part of it. So right here, it's going to run its way around. The visibility tab here is where you can turn your fixture on and off. So if you say hide it, you can actually hide your fixture and watch your part run. I'm going to show it, and I'll speed up just a little bit. Actually, I'm going to go ahead and turn on my workpiece view and just show my fixture. I don't need the part to move around. There we go. So there it is. So we'll let that run the advanced rough. And shortly, we're going to get down to where we start getting into the clamps, and we're going to lift up over them. So it still knows it's tall enough to clear the clamp there, so we're good. And there you'll see it's going to start going up and over, just the retract. But you'll see then it creates a wall, and it's able to squeeze through that gap up until it gets to a little bit here. Now, we got some collisions between how we're entering the material, how we're just plunging in. Sometimes you'll get an error on just the plunge move, so just be aware of it. Those aren't errors that concern me one bit for actually machining this part, so I'm not even going to worry about it. Right there. And you could give it more between your cuts that you make. You can go 30 thou. I went 20 thou. It's pretty tight. It's going to be scary the first time you watch it, and then after that, it shouldn't be too bad. But here is the advanced rough. So that's what we're going to be left with after the advanced rough. And then we're going to start with the advanced Z-level finish. And this one's going to go in and just work its way down. And same thing, when it gets down to near those clamps, it's going to avoid them. It's just going to ignore that area. So you do have to be concerned with, well, one, we're taking a heavy cut right there, and our tool is cutting through the part. And it looks like cutting through there. I'm not sure. That must be the flute length. So I'm going to go change the length of the tool to fix those errors real quick. Now, this one's actually super simple in 35. If you go down to the Operations tab here, and down here you have your operations, which is kind of the order you're running everything in, with all your features listed out. But right here we have our tool tree. And I can actually right-click on this 3/8 tool and say Edit. And for this one, I'm just going to say the protrusion length is 2.5 inches. I'll hit OK, and you'll see a little symbol pop up, and that means we need to recalculate those tool paths. So I'm just going to right-click on this 3/8 tool here and say Compute All Tool Path. You could also see when you right-click on there, for those of you that don't have a tool changer on your machine, it's a really good way of posting all the code separately. I can right-click on this 3/8 ball and say post just the operations that are using this tool. All right, so there they are. Now we'll go back up to our, well, let's hit save first. And then we'll go ahead and do our start simulation once again. All right. We'll just wait for that to load. All right, so once again, we'll go visibility, turn on our fixture, and say run. And hopefully this time we don't have any gouges, or I need to make my tool different, or I did something else wrong. I'm not sure. There it is. So you do have to be aware you are going to get into some heavier material there, but if we get our feeds and speeds right, we should be good to go. So there we have it. So let me go ahead and turn off my fixture for now. Right here. And that's it. That's what we have left over. You'll see it avoided around those clamps. And you could go, you can make the clamps, a little bit bigger or give your allowance a little bit more so you don't go so close to them, because even then it's only 20 thousandths there, so it's still a little scary. What I want to do now is I want to take this model of this stock and I want to save it so that I can go and clean up these two sides. I made this fixture so that I could take this part, turn it 90 degrees, and then go and clean up that finish right there. Now, because we're changing the stock, it has to be done as a separate feature, as a separate job. So I'm going to do it all in one window and one cam tree, but you could take and just move to another window and make a whole new job. But for now, I'm just going to go down to my Cut Sim tab, and I'm going to say, let's go ahead and save our stock. I'm going to save it with, yeah, I'll save it there. This is going to be my Op2 stock. I've already saved a copy because, like I said, I was messing with this just an hour ago. And so we'll say save. And then yes. We'll give it a second to save. And then we'll close our simulation. Now, at the beginning of this, I mentioned I have two models, an Op1 and an Op2. They're the same exact file. I thought they were a little different when I rotated them, but I made it all kind of symmetrical, so it didn't cause any problems. So what I want to do now is I want to open that piece of stock, that STL file. So I'm just going to go up to File and Open, and I'm going to change this to STL. And I'm going to pick that Op2 stock right there. And there is my stock. Now what I need to do, because I don't want to move the fixture at all, or I don't want to have to move the fixture. What I'm going to do now is I'm going to go ahead and rotate that stock 90 degrees. So I'm just going to go to Utilities and Rotate, pick the whole part, and I'm going to go around Z 90 degrees. And that's going to put those two little imperfection areas right there on the front and back. So my clamps will be on this side now. And I'll go to File and say Save As. I'm just going to resave this as an STL with the same name. And it's going to save. So like I said, I can't use a second machine setup here. That's I was messing with it earlier trying to figure out a good way of doing it, but the part doesn't get rotated. Your milling job has this one piece of stock in it. So for me to bring a new piece of stock in and see it cut properly, what I have to do is actually start a whole new job. The difference is on this one, when we go to our stock wizard, workpiece, yeah, that's fine. We'll pick the workpiece. The stock type we're going to use instead of a solid is going to be that STL that we just changed. So I'm going to say browse. I'm going to pick that Op2, hit open, let it calculate. That's not right. I might have the other stock showing. Hold on, let me hit OK. Yeah, there we go. Okay, so I blank out that stock. Let me get this whole thing shrunk up. And if I turn off my models for everything, there is that STL. So not too shabby. Now I was messing with this and the Z level doesn't want to go that deep. I couldn't figure out why, but I was playing around with some other options for toolpaths and I came up with a really nice one, which we're going to use the project curves. Toolpath, a lot of you guys might not use very often, but we're going to go ahead and use it. So first I'm going to pick my fixture right here. So I'm just going to say fixture, reselect, pick my whole fixture, hit OK. And then I'm going to right click on machine setup 1 here. And you know what? I'm going to cheat this a little bit. Because this is a new job, it has a new tool crib in it. It's an all new set of tools. So just to make my life a little easier, I'm going to take this feature 3-axis that I've already created that has the correct 3/8 end mill in it. I'm just going to copy it and I'm going to paste it under this machine setup 1. I'm not actually going to do anything with that toolpath. I'm going to delete it in a few minutes. But it has the 3/8 tool in it with the correct size. You know, everything I changed already is already there. So now I'm going to right click on machine setup 1. We're going to do a mill 3-axis. And we're going to select our geometry. Now the geometry for this, again, model 1 and 2 are the same. So I'm just going to pick the whole part and then hit OK. And then go next. Right here for the strategy, or right here for the feature, nothing to change. Next, we get our strategy. I'm going to go ahead and choose the project curves feature. Now, you could also use the equidistant in a very similar way. Essentially, both of these tool paths allow us to pick wireframe or curves for the tool to follow. So I'm going to go with the project curves right there. Next, we have our arc fit, so I'll make sure to turn that on. And then right here, it's got our tool number 2, our 3/8 tool. That's the reason I copied that other tool path, is just so this thing shows up properly. Right here, we have our patterns. So with this one, I'm going to do my projection curves. And what I'm going to do is I'm going to say, let's go ahead and project that curve right there outward. And I'm just going to scroll down and hit OK. Now, to get it to go outward, we're going to use an offset type. Now, left usually means inside. So it's going to put us on the inside for however many passes we tell it. I want to go to the right. I want to be outside of that boundary or outside that geometry we just selected. Now, if I go with 0, we're going to cut a whole bunch of cuts. But I'm actually going to leave that for right now, and I'll show you why. So for here, we're just going to do a climb mill, standard, all great. Next. Right here, I'm going to give it just a 25 thou step over. And then I'll go next. Leads, not going to change anything there yet. Options, no changes here. Don't need angle ranges. Links, just give it an S-link. Gouge check, we will be using this, but again, I won't use it right now. And then that's it. When we're all done, we can hit compute. And we'll just wait. And you'll see it cut a lot of stuff. It did not cut anything in the middle, though. So let me shrink up this job and do a blank on that. So you'll see it took that outside shape and it offset it outward. So what I do now is I go in and I count. This is, we'll count this pass here. So 1, 2, we got 3, 4, 5, 6, 7, 8, 9, 10, 11. What I do now is I edit my project curves feature, go down to the patterns page, patterns, and say I want 11, let's do 12 passes. And then again, I'll hit compute. And this is going to limit it by itself. That's all limited right there. It's only going in and cutting that area. Problem is, as of right now, we are going to gouge through our fixture because we have that there. Really, I don't even need it to go that far. So I could, if I wanted to get crazy, I could use some boundaries for this, which is a lot of times how I would fix these. Those of you that have been in my class and been in my, worked with me on 3-axis before, I rarely use gouge checking to avoid cutting an area. I usually just use a boundary. I'd set up a boundary and say just cut inside this boundary. And this one would be fairly simple, just a couple of rectangles. But I'm going to go and use my fixture and turn on gouge check. So with this one, I'll edit my feature, go down to my gouge check tab, turn on that checking. Again, say we have some check surfaces and I want to stay 20 thousandths from them. And I want my strategy to trim and relink the toolpath. Or let's try the Retract Tool on this one. So with this, I'm just going to do the same thing. Go to a front view by hitting Control-2. I'm going to drag a box over this whole area here, just like that. And I'll hit OK. From there, I'll just hit Compute. And we'll see what we get. And there it is. So you'll see with the Retract Tool, it just retracts the tool up and over it, not clear of it, and it's going to be cutting. It's going to be moving at our cutting and plunge feed rates. So another way to fix that, we edit this. Remember, you could double click on your features to edit them. Go to Gouge Check, and all I'm going to do is change that to trim and relink on the collisions, and then once again compute. And this is going to raise it up quite a bit higher. All right, now the problem is, and this is the biggest complaint I have, and I'll try and figure out a way around this, but I can't simulate this all at one time now because I need my stock to rotate in between the two operations. So if I right click on my first milling job and go to simulation, I'm going to run the first set of ops. And then down here, the second milling job, I'm going to right click and go down to simulation. Now, when this one loads up, the stock that we brought in, all right, the stock that we brought in is going to show up. And would you say, Eric? Yeah, throw a quick boundary. Yeah, I would normally throw a boundary on this, but with the gouge check, some guys try and use it for any reason. So I want to show them that you could use it. But again, boundaries, just 2 little boxes right over that. 2 little boundaries there would be enough to control where this thing cuts. All right, so turn our fixture on this time. And you'll see that part is rotating. Again, that's the whole reason why we can't do it in 2 setups. I love doing things in multiple setups because then I get to see the final result with the part all flipped around. but we can't do that this way. So there it is. You know, there might have been a way to do it, but just by rotating our origin and saying our part was this way. Yeah, there could be a way to do it. I'm not going to do it though. So two separate operations, essentially. Basically, we could make this as two separate files, one for the op1 and a separate file for op2. And now it's going to go in and we'll say run, and it's just going to cut its way around and just clean that little edge up for us. And none of this is perfect. None of the finishes I'm using are really that great. 50 thou, this one's at 25 thou, and I'm using a ball mill coming down to a sharp corner. Had I put a little fillet in there, it would have worked a lot better, but I didn't put a little fillet in there. And so it gets to the point where the tip of the tool gets down there and then it can't cut any further. Can't go any deeper, or it's going to gouge into that floor. So definitely have to clean that up. And had I planned this out better, I would have figured out what size V tool I could potentially use on that. If that's the case, lots of things we can do. But there is the finish to everything. All right. So that's going to be your operation stock, and then just fixturing in general. If you can draw it out as a fixture, or go online and find your fixtures, or even if you want to be as simple as, you want to see your vise in a part, you can go on Kurt's website, or anyone you really probably buy your vices from, most likely Kurt. You can actually go on their website and download models for your vise, and you could bring them into BobCAD, and you can situate your part in the vise, and then you can make sure, again, the biggest thing with any of this, anytime you're trying to do this where you have a fixture, you have to be as accurate as you can possibly be. If you're not accurate with it, it's not going to work really that well in the first place. If you're not perfectly accurate, you're going to be off in some way. Let me see if I have some part files. I had one. Might only have them on my laptop. Oh, yeah. Let me see down. Yeah, I got them on. They must be on my laptop. I'll find some. We'll find some more. But yeah, that's it. You set it up. So if you want to bring things in, like let's go. I'm going to pull up a website here, and let's do Kurt Vice. Whoops. Kurt Vice right there. Kurt Vile. Kurt Vices. Did I spell that wrong? It is with an S. Dang it. All right, here's Kurt Work Holding. Let's go to a single station vise right here, a little 6-inch single station vise. So we got the crossover. You can download most of these files, but if you click on it, most of the time in here, you can go down and find the 2D, 3D CAD. And then in here, we'll say click to load. Okay. And we'll say, let's get this thing as something easy if we want. You could go and use like a step file or an IGES. I'm going to go with just the step file. And then we don't need it zipped up. Yeah, it's fine. So we'll say download. All right. So I have to click this right here to download the file. There's the step file loading into my downloads folder now. And so the way I do this is I open up a new blank window, or actually you didn't even have to open a new window, because when we open this step file, and I'm just going to drag and drop it into BobCAD, I want to keep it original and hit OK. And wait for it to load all the way. Yeah, there we go. So there is my vise now. So first thing I'm going to do is get this thing situated properly. And the nice thing about this is you can do this right when you get it, and you can save this file, and you can use this for many jobs. All you got to do is open the JAWS. So I'm going to go right here to my utilities, and I'm going to start by saying, let's rotate this. And I want to make sure all the layers are on when I do this. Pick it. First rotation I'm going to make is to lay it down flat. So that's flat on the table. So I'm going to go to X right here and say, let's go 90 degrees. And I know it's 90 because the direction the arrow's pointing in is positive. Anytime you look at an arrow, the positive direction is what we're pointing at. So there's my preview. I'll hit OK. And give it a second. And then I'm going to go in and zero out the X. And then I want that handle towards my door, which is going to be this way. So I'm going to drag a box over the whole thing once again, and then say Z. We're going to flip it. This is going to be a minus 90 because we're going against that arrow. So Z minus 90, and hit OK. And then eventually cancel out. So there we have it. Now, once again, this thing is currently sitting, looks like right at 0. So I'm just going to go to a front view and verify that. Yep, we're sitting right at 0. So we'll be able to bring our parts into here. So if you know you have some, from the top of the jaw here down to the, I got my part sticking out. Let's do this real fast here. I'm going to take this whole file real quick and just copy it. So home, copy, give it a second. It's a big file. And then I'll jump to a blank window here, and I'm just going to call this one, fixture. All right, and I'll paste it in there. So give it a second. There it is, and fit all. So the reason I did that is just so that I can now bring in my part. All right, so just like that. Go to my fixture part right here. And what I'm going to do is I'm just going to grab the solid model. I'll grab the solid model for this. So I'm going to grab this and go home, copy. I'm going to go ahead and take the Kurt Weiss, BobCAD 2 here. And I'm going to go ahead and paste it. So paste right there. So you'll see where my part got pasted at. And that's not where I need it to sit. What I need to now do is figure out, with this one, I'm going to have, we'll say, 100 thousandths of this part sticking above this jaw. So what I'm going to do is I'm going to go to evaluate and measure to. And I'm going to find out the distance right now from here up to here. And in Z, it's 3.6428. So I'm going to copy that value, cancel out, go to my utilities and translate. And I'll just turn off the fixture for now. Pick my part, punch in that number, click out of the box, get our preview. And if we look at our fixture now, you'll see right there, we'll hit OK. And that's going to put that edge perfectly aligned with that, height-wise with that face. All right. So now what I'm going to do is I'm going to go to translate once again, but I'm just going to say in Z, let's go 0.1. And we'll move this guy up again and hit OK. Now what I need to do is move it, or really, I like this where it's at because it's located on 0 there. So what I'm going to do is I'm going to move the vise, the whole vise, over to we're going to go to the left a little bit so that edge aligns with this edge. And again, I'm just going to go to evaluate, measure to, measure this edge, and just get the distance from that edge to there. And what I'm looking for is my distance in Y. So it's 163, so 0.163. I'll turn off my part, go to utilities and translate, zero out Z, Y 0.163, pick it, pick the vise, there we go. It's going to shift over just that little bit and I'll hit OK and cancel out. So again, there is my part. Whoops, hold on, I'm just waiting on it to load. There we go. And now we have our edge butted right up against it, 100,000 sticking out. We can then take this assembly part of the jaw here and do the same thing. So I'm going to do my evaluate, measure to, and I'm going to measure from this edge here to this edge here. We're looking for our distance in Y. It's 3 inches. Beautiful. Easy number to remember. So we'll just do a utilities and translate. Just make sure that you grab all of the geometry for the movable jaw. So a lot of times what I'll do is click Control 1 till I get to my side view right here, which is Control 5 and Control 6. And I'm just going to pick that geometry right there. I want to go pretty deep into it because it does have some screws and stuff in it. And I'm going to tell it, let's go ahead and move in Y 3 inches. Now, not everything has to be exactly perfect, like down here. I don't really care what's going on down here. It looks fine, but we'll go ahead and hit OK and cancel out. And there we have our part. So sitting in the machine or sitting in the vise just like that. Now, again, if you're very accurate with this, or as accurate as you can be, you can use this as a fixture. And you can tell the tool to ride right on top of those jaws. I'm not going to do that, but what we'll do now is we're going to go and start a job. So I'm going to right click, say new job, BC3X mill, stock wizard. There's my workpiece. This time I'm going to do a big rectangular piece of stock. So just like that. And I'll go next again. And then this time I'm going to use top dead center on this one. So I'm not going to go off the vise. Or actually, we'll go back left corner of the stock. We'll go there. And then again, I'm going to scroll down and actually, since the bottom of our vise is there, oh, this is perfect. This number right here, the 7.0696, that's the distance I need to move this whole thing up in the simulation. So I'm going to copy that and I'm going to enter it into my Z right here. All right, and that'll make sure that my vise is actually sitting directly on my table. So I'll hit OK. And then just to make it a little quick, I'm going to go over to my features where I already did some toolpath. And I'm just going to copy this feature, bring it back over here. I'll go ahead and paste it under machine setup. And then I'll turn off my fixture so I can go in and pick my geometry. I'll pick all that. Now with this one, I mean, this is a pretty standard kind of job here. I in this one wouldn't really usually pick gouge check geometry. So it's not something I have to pick. There's my fixture real quick. I'm just putting that in place. So I got my fixture picked. If you did have it, like I copy and pasted the toolpath that has gouge check turned on, if I go to compute this right now, it's going to tell me no surfaces for collision checking were found on all three of those toolpaths. So I can either go in and turn off the gouge check on all three of those toolpaths, or I can pick the gouge check geometry. So what we could do there is expand the advanced rough and expand the gouge check surfaces. Right click on it and say reselect. And again, I'm going to hit Control 5 so I can pick the jaws right there. I don't really need to worry about the base of it, but we'll pick the jaws and hit OK. And then I'm going to do the same thing for the advanced Z-level finish. Right there. Hit OK. Shrink it up. And then finally, we'll do the same thing for the advanced planar. And now we're actually giving it the right geometry, though we really don't need it all that much. So now that we have that done, I'll go ahead and do a save as with, part file vise. Oh, caps lock's on already. With toolpath. So save. And now that we have that stuff picked, we shouldn't have an error come up again. Give it a second, I'll save. All right, so now we're going to go ahead and compute right there. All right, come on. This is on to the last one. And you'll see there's our tool path right there. You'll see it did cut around the sides here to get down next to that side, and it knew that that wall was there, so it stopped short, and we shouldn't run into that vise at all. Let's check out the Z level. Whoop, let's blank them all out. Here's the Z level. Just going in and cutting that, and then our advanced planar. So again, with a vise, if your part's sticking up above the vise, you really don't have to worry about gouge checking. Gouge checking is really, for me, one of the biggest times I use it is when I do have some fixtures, that are sticking up around my part. But with a vise, I'm at the highest point right here. This is as low as I want to machine, really. I'd even come in and usually tell this advanced rough, don't even worry about cutting all this. I'll have that thing probably cut to shape first anyway. So there we have it. So now I can go in and start the simulation. And again, because I have the Machine Simulation Pro, if I turn on my machine setting right here when it loads up, come on, there we go. If I change this here to machine, you can see there's my vise, wherever I want it. I could even go and set up my origin off of the vise. I could have picked my origin off my solid jaw back here and used it that way. So now I could go in and run it. And the tool path shouldn't be too much different. I just hate looking at it like that. Let me do this and turn on the fixture. So there it is. And again, we shouldn't hit the vise anyway. I mean, this is a pretty straightforward part. Had we not picked the gouge check, though, that advanced rough could potentially run right through the vise. And the reason it would run right through the vise and not even care about it is because when we picked our geometry, we didn't pick the vise as part of our geometry. We didn't tell it that the vise was there. So since it doesn't know that it's there, it won't avoid it. But by using gouge check, it knows that it's there. That's essentially what you're using gouge check for, is just to tell the system that there's other things. So it's just working its way down. And then little cutouts in those corners. Not much needed there. And then we're doing those intermediate steps, just working our way back up. And then we start our Z level, advanced Z level, right there. And then we have our planer. And again, that one shouldn't be going really close enough to matter. It should be hanging over the vise anyway. So there it is. Any questions? Anything you guys saw that you didn't understand or anything at all? I planned this whole thing out and thought it was going to be a lot longer, so I'm kind of out of things. So if anyone's got anything they want to talk about or anything they want to see, let me know. Otherwise, yeah, thanks for coming. It was a pleasure. Hopefully this helped you guys a little bit. Hopefully some of you will use this. I don't know. It depends on your fixturing and really how much you want to draw. Because a lot of times, even with this one here, you know, I most of the time would not be drawing all of this fixture here. I would really just draw these couple of clamps right there. I would honestly just some little cubes right there, right there. I'd just draw some little cubes and put them in there. Maybe a little arm or make them a little wider. But really, it doesn't have to be the most accurate, drawing that you can. If your engineering department's putting together these drawings for you that are going to have the clamps on it and do all that, you might as well. It's just going to be better for you. So there it is. All right, while I'm standing here, I want to do this real quick. I'm going to just do a little rectangle here, and I'm going to put it right there and right there. Oh, I did have an edge. Hold on. Let me try that again. Rectangle. Let's do yeah, that'll be fine. So I'm going to put one there, and I'm going to put one there. Now you can see this is quick, real quick one. But I'm going to go into my feature that's doing this final, let me delete this thing, doing this final project curves, and I'm going to pick those boundaries. I'm just going to hold shift and pick them right there and there. And this should trim off all the rest of it. And hopefully not go into my part, otherwise I'm going to be more accurate with this. But I'm going to try it this way. Compute. And there it is. There you go, Eric. There's your, that's a quick one. And it's probably even bigger than it needs to be there too. So there we go. All right. So yeah, like I said, that's pretty much all I got. Let me go ahead and stop the recording here.